Good afternoon, everyone. Welcome to my presentation, Making Let's Encrypt Relay, NolaCon 2019. Who am I? My name is Josh Harvey. Currently, I'm a Senior Principal Systems Engineer at NASA at Goddard Space Flight Center in Greenbelt, Maryland. I've been working in IT for a little over 10 years. Started with Apple, and then about a year after that, I made the jump into government contracting, and they had cookies and paid a lot better, and it wasn't retail. So let's get started. Here's what I'll be covering throughout this presentation. We'll start with an overview of why the relay was created, along with its benefits and features. Then we'll move on to what the requirements are for it, how it all works, along with some examples of it in action. If everything goes according to plan, there'll be time at the end of the presentation for any questions that you may have. Hopefully answers too. So why make it? The idea for the Let's Encrypt relay came due to some issues we were facing in our environment, mainly with internal servers. We're always creating new servers for deployment, testing features, internal wikis, the list goes on. But there are always issues that we face with it, and the pushback and delays that came with getting these internal SSL certs, it was starting to affect the main reason why we stood these up, and that was to do the testing, to do the development. And being able to focus solely on testing is important. So we thought about the main issues that we were facing, and came up with these four main issues. HSTS requirements. HSTS, it has to be set, enabled for all servers, internal, external. It has to pass all the checks and the box has to be green. Otherwise, I get yelled at. They were difficult to get. Requesting internal SSL certs either required filling out multiple forms, waiting for somebody to get back to you about them. 9 times out of 10, they were rejected because they were development servers, or maybe you got lucky and they got approved. Either way, development servers, their requests always took the back seat. So that held up testing. Untrusted with our Java applications. Throughout where I work at, we use a lot of Java apps, and internal SSL certs, they didn't really work with most of the Java applications that we used. They were untrusted and kind of made testing and using it difficult. And lastly, there's the cost. Purchasing SSL certs from external CAs, it costs money, and that requires approval. And because it's a development server and using it not for production most of the time, it's kind of a waste of money and it's hard to get approved. So here comes Relay to the rescue. The Let's Encrypt relay allowed us to get HSTS support. It can be configured, and it's no longer a 4-letter word when we have to go set up internal servers. Certificate management, this was a real big plus. Using the relay, our users are in control of all the SSL certs. They can create, by taking the request process out and the delay, the folks can go back to testing, and we can start sooner than ever before. You're in control. Along with the certificate management, the Let's Encrypt relay also produced trusted certs they were trusted with Java applications. They were accepted, and they worked with every single one that we used, which no longer put limits on what we can test before we have to start the long process of requesting an external SSL cert. And last, they're free. And who doesn't like free? I like free. My bosses like free. The average for a 1-year SSL cert is around $150 to $200 a year, and that can add up fast. So free was definitely a huge bonus. So next up, let's talk about some of the features and the benefits the relay provides. Besides solving the issues previously mentioned, there are additional benefits to using the relay. It was quick and easy. I mentioned this in the previous slides, but it's a big part of why I made the relay. It makes SSL cert management extremely quick and easy, all due to the fact that each user is in charge of their own SSL certs. They can manage them, they can renew them, they can create them, and it's all on their own. They have the ability to connect to it via SSH. Your servers stay internal. With SSL certs going through the relay server, there's no need to open up port 80 anymore. This not only increased security for internal servers, because the less ports exposed, the better, but it also cut down on the number of firewall change requests being submitted. And from what I'm told, everybody who was in that group was a lot happier because of that. It meant less work for them. Another benefit, it's automation friendly. Being SSH based, users can create scripts and playbooks to manage or create or do whatever they want with their SSL certs. And I don't know a single system admin who doesn't love to automate something. I automate everything I can. It's user isolated, so each user that connects to it, they're in control and they can only see, touch, do whatever they want with their certs. That's it. If I connect, I can see my certs. My coworker, he can only see his certs. So it's sandboxed just to that user account. Along with being isolated, it's also secure. By using an SSH wrapper script, which I'll get into in the next few slides, we can limit the access normal users have when they connect to the relay and what they're allowed to do. So we've talked about the benefits, we've talked about what features it has, how it resolved a lot of the issues that we were facing. Now let's go over the basic requirements for the relay. And we're going to start with the server side. These are the basic requirements to stand up a Let's Encrypt relay server. Sure, you could use a Windows server. Sure, you can use pretty much any web server you want. But because I was comfortable with using a Unix-based OS, I decided to go on CentOS on an ESXi host. I had easy access to it. I use it every day and figured why not. Same thing with Apache. Just the default installation of Apache with a virtual host configured for port 80. And that's for the DNS challenge that occurs during the creation and renewal process. Next, you're going to need the certbot client. And that's what does the communication to the Let's Encrypt servers. And finally, you need the SSH wrapper and the cert menu script. I've mentioned the wrapper script and the cert menu script. And we're going to go over them in more detail over the next few slides. But these are the main two things that allow all the magic behind the scenes to work. It allows the automation to take place, the sandboxing, and they're key components to this relay server functioning and working. So after the server requirements, we have the usage requirements. And the first one is local account has to exist on the relay server. Now, depending on your setup, if it's bound, if you have your SSH key, your public SSH keys published, it doesn't have to exist. But for our setup, the account being used, the service account or the user account, it needs to exist locally on the relay server itself and have its public SSH key copied over onto the relay. The final piece for the local account, it needs to be a member of the group, which we'll get into a little bit more later on as well. In these examples, we I've been using certbot users. And in order to automate, because I love automating, I use a Ansible playbook to create the local account, copy the key over, and add them to the certbot user group. I mentioned, depending on your setup, the end goal for the relay in my environment is to bind the computer and take advantage of the public stored or the stored public SSH keys. So that takes this usage requirement out. The next one is the CNAME has to be added to the public record of the relay. And this has to happen, as you can see, I have public underlined. It's because it's a really important piece, and if you register it to the public and the private, I've made this mistake and your server becomes unreachable. So I thought I would underline that as well. To prove control of the domain being requested, the host name for your internal server needs to be added as a CNAME. It's important, like I mentioned, it only takes place on the public side. And this will allow those challenges to occur. So what's next? Well, we've gone over the basic requirements. So let's dig into a little bit of how it works and how all these pieces come together and interact. Here's a high-level overview of the basic steps each connection will take when it's using the relay. Using the account that manages their SSL certs, user connects to the relay via SSH, and the SSHD config checks if the user connecting is a member of the certbot users group and runs the SSH wrapper script if so. The SSH wrapper script then looks at the connection request and filters it based off that. For example, if you're using SCP to copy your SSL certs over, it'll leave that alone and allows the copy to start. If it sees that it's not a SCP or SFTP request, it will then kick off the cert menu script and pass off any original arguments that or options that you added to the SSH connection. Once the action that you're trying to do is finished, connection to the relay is automatically closed and the job is finished. So I've been mentioning the SSH wrapper a lot, and I have an example of the wrapper script itself. If a user is a member of the certbot users group, the SSH wrapper script takes over. I went with an SSH wrapper due to the flexibility it allows without impacting security. As you can see, it's nothing extremely complicated at all. And I went with this over a TCP wrapper because we have people who are going to be using this all over different networks internally. And this was an easier way to restrict access and not make it really complicated. So as you can see, the script, the SSH wrapper script allows any incoming SCP or SFTP connection and forwards it along to do what it needs to do, whether copy the certs down. If it doesn't recognize or doesn't see the SCP or SFTP command, we can see it's going to force the cert menu script to run. It's going to forward the original command along with it, and this is the one half that makes this whole process able to be automated while keeping it secure. So this cert menu script, mentioned it. This is what interacts with certbot and allows users to create, renew, or list their SSL certs. There are two ways to use the cert menu script. First way is interactive, and the second is command line. And the command line just means you can put everything on one line and It's the way you're going to use the relay if you plan on automating. Like I'd mentioned, this gives the user several ways to manage their SSL certs. In the example under the interactive option, you can see the SSH connection request, followed by what the user is looking to do. In this example, it's to create a SSL cert. Once the SSH wrapper passes this along, the cert menu script then realizes that it's trying to create a cert, and it's going to prompt the interactive option of the certbot menu, which we'll get into. I have an example of both of these as well. In the example under the command line option, you can see it starts off the same way with the SSH connection, the user, the relay server address, but within single quotes, we have create and then the domain that you're going to be creating the cert for. This will allow the entire creation process to be completed, and your cert is done without passing any extra options or interaction required. And this is how I automate a lot of my SSL cert creations or renewals. So let's take a look at the beginning of the cert menu script. And this is how this takes the output of the SSH wrapper and processes it for use. We can see the original SSH command is converted to all lowercase, and it's saved to a variable. This variable in this example is SSH option, and it's being converted to lowercase to make the case statement, which I go over in the next slide, a lot simpler. Takes out a lot of margins for errors. You can see the certbot variables being set on the lines below. This allows certbot to run in each user's home directory, creating a sandbox just for their SSL certs. And now that we have everything set, let's take a look at the case statement that actually does the magic. This is the case statement that runs the various options aloud. In the beginning, I mentioned how the SSH wrapper allows SCP and SFTP commands through, but redirects anything else to the cert menu script. And these are the available options. I know it's hard to read on the screen. I have these slides posted online as well. But the options available are renew, PFX, which allows users to convert an existing SSL cert for use with IIS, the option to create, a help and usage option, and then last but not least, an option to list all of the SSL certs that you've created or that you manage, which is really awesome because it tells you how long those certs are valid for, where they're saved at, and the save location can be used for copying it down. This case statement will look at the SSL output variable and match it to one of these options. If the variable doesn't match any of these allowed options, it'll call a function containing the script usage and then exit with an error code 1. So these are the only options available to your relay users. Anything else, it just gets kicked back. And this section helps restrict access and usage so that we can keep the relay and everyone's SSL certs safe. So we've gone over the cert menu script, the SSH wrapper. Well, how do we tell it to point to these? And that's where the SSHD config comes in. I'd mentioned briefly in the beginning that the user has to be a member of a certain group. And here's where that certain group is referenced. We do this by adding a match group conditional block to the SSHD config. You can see we're defining 3 options inside of this match group. Password authentication. We already have the user's public SSH key. So we disable the option for passwords to be used. This also helps us control who has access to the relay and avoids us having to manage passwords. Next, we have the force command, and this is what automatically runs the SSH wrapper script that we covered earlier, and forwards the original SSH command being used. And last, the last option being passed to it is the authorized key file. This sets the location where the public SSH keys are stored. And adding this option allows us to control where we want those keys to be stored at. And by changing it and making it to a non-default location, we're adding another additional notch of security on where and who has access to these to the relay. So after talking about how the relay works and what files are needed, what each section does, it's time to take a look and see where all these files go. This is an overview of where all the required files are stored for the relay. I set up to capture the examples on the next couple slides. I haven't mentioned installing Apache or creating the virtual host in detail because it doesn't require any special settings outside of the default installation. As you can see on this slide, everything we're doing is either in the etc SSH directory or the opcert directory. Once you have Apache installed and the vhost created, we need to create the group that will be used in the SSH config and where we're going to add the relay users to. Once the SSHD is configured, we can copy the SSH wrapper script and the cert menu script to the opcert directory, which is the directory I created during the process because it was easy for me to remember, and that's pretty much the only reason why. Any of these locations, for the most part, can be customized. I just made it paths that were easy for me to remember. So let's take a look at some examples and see how this actually works. I've talked about it and shown what the scripts look like, but let's take a look. In this example, I'm doing creating an SSL cert and choosing the interactive option. So I'm not going to add anything after the create. So you can see we're starting off with the user nibbler, and we're connecting to my Let's Encrypt relay server. We have the banner, and it's going to prompt me for what my FQDN is that I'm creating the cert for. It'll ask me to verify it. It'll also ask if you have any subject alternative names that you want to add to the cert as well. This allows you to nest multiple domains under one cert. And we're just going to verify by running the list command. And this was an example that I took after creating all of those certs. But the user nibbler has control of all these certs and manages all these certs. And we can see they're all stored in the same location, in the user's home directory under SSL and live. Next, we have creating an SSL cert. Then this is the command line option. This is the best way to automate, as I had mentioned earlier. And we're starting off the same way as before. We're using Nibbler to SSH into the relay server, but now we're making an SSL cert for Zoidberg, and we're all doing it on one line. And we can see it starts off the same. But instead of giving us that automated or that interactive option to verify, it's going to go ahead and automatically create the SSL cert. And as you can see, at the end, it's giving us the path, and running the list command gives us the newly added cert, valid for 89 days for this domain, and gives us the location that it's saved to. And I've ran this command both times after, just to verify, but this is another way you can automate this. You can take the results of this and use it to parse. You can pull the certificate path. You can just see if your certs, what certs you have. It's just another feature that it really helped me because I'm horrible at remembering things. So being able to quickly see what certs I have and when they expire was really helpful. I had mentioned the case statement blocking or stopping any option that was passed that isn't an actual option, and how it adds to security and just exits. Here's an example of how that looks. I know it's kind of small, but the usage is really big, which you'll see after I'm using the get command, or the get option. And it gives you overview of what the available options are with examples and a little bit more of an explanation onto what each one does. And so we have the main options, but what happens if we want to copy a cert down? Well, here's an example of the SCP option. So instead of using SSH, we're just doing a normal SCP command for the user nibbler. And this is where that list command really comes into play, because we're putting the entire path to whatever directory or whatever cert we want to pull down. You can be as descriptive and pull one cert. You can pull all your certs. It doesn't matter as long as it exists. So we're pulling the Planet Express script down, and we're going to store it in the temporary directory locally. And we can see, because it's using the SSH key for authentication, it's quick, it's easy, and now we're going to just verify that Nibbler got his certs for Planet Express, and they exist locally now in the temp directory. And we can see we have all the required certs, so we can move on and make our web servers compliant. And the last example that I have is the convert option. We have IIS servers that do a lot of hosting, and in order for Let's Encrypt cert to work and get installed, it has to be in a specific Windows format, and that's awesome. And I always forgot the command to convert it, so I decided to automate it and make it easier for me. This cert has to exist on the relay itself, but once it does exist, we started off just like a normal SSH command. It's a little small, but I have all these examples posted up, and I have a link for my GitHub repo that all these files are on. But as you can see, it's asking for the export password, and in this case, I used a super secure password of blank. But it exports as a PFX file once the option and the domain that you're creating it for are passed through. Then you can just use the SCP option to copy it down, and life goes on. References. I had mentioned that I have all these files, the SSH wrapper, the cert menu script, the SSH the config examples, as well as the Ansible playbook that I use to create and add users with a randomized password to the relay. This is my GitHub repository that contains all that. So that way you have the ability to create a Let's Encrypt relay server in your own environment. Also, because this was a really helpful page, the CertBot homepage. During the creation of this, it was really helpful and showed me how to sandbox the creation of the SSL certs. And I think we have some time for questions. So, any questions?
How does your wrapper, or how do you handle requesting a wildcard cert?
Haven't tested that. That was the I added the feature to create or to use the additional stands to kind of get around that, to add multiple ones. I'm sure it would be possible to add it, but it's something just we haven't tested. Cool. Well, no other questions. Thank you for listening.